Hi, welcome to ApertureData's video on our multimodal AI workflows, the newest feature we've created to help you get jump-started in multimodal databases. I'm Joe Ogle, Senior Engineer at ApertureData, and today I'm going to go over the workflows we are releasing with our first workflow set in March 2025. Workflows can mean different things to different programs, so I'll describe what workflows are for ApertureDB. They are processes you can run which will add, transform, or help you access your data. They are single action, like loading a dataset, constantly running, like a Jupyter notebook, or on demand, like embedding instruction. They are configured per database and run alongside your database in Aperture's cloud. The goal of workflows is to allow you to easily set up common tasks that are needed for multimodal data so that you can focus on using this data. The workflows already available on ApertureDB Cloud right now are dataset ingestion, embedding extraction, object and face detection, and Jupyter Lab. To test these workflows, you need a cloud account for ApertureDB. It's simple to set up and comes with 30 days free of a fully functioning instance. Once you have an account, you'll need to create a database instance, which it will ask you to do as part of initial account creation. If you didn't do that, just follow the instructions here. Once you have that, you can go to the Workflows tab up at top. The first step is to get data into your database. If you don't have your own data, you can use your dataset ingestion workflow to add data. Just select a new workflow like this. Choose dataset ingestion, choose your dataset. Our Cocoa load is 5,000 images, which is perfect for testing, and you're good to go. You'll know that it's finished once it says finished here in the status. The object detection workflow is one of our on-demand workflows, which will process images in your database and add bounding boxes for the images in them. Now, let's add object detection. Click on Add, and you can see the workflow starting here. Once it is started, it will look like the workflow down here that says started, which means it will have started processing the images in your database. Now, let's go to our UI, which can be found in My Instances and Connect, and click on this link. The password to get in will be the one that you've used when you created your instance. This is an overview of your database. We're going to do an image search. Click on Image. We'll do 5 image, and we'll do some properties, Cocoa URL, WF embeddings clip, and WF OD model. We're going to sort by Cocoa ID so that we have the same images, and we're going to run. Here, it's detected a stop sign, even though it's upside down. And here in this living room image, it has 3 detections. Notice that these bounding boxes are rendered on the client side and not stored on the database. Now let's talk about the next workflow. Face detection is much the same as object detection, except it uses faces. So we'll gloss over that for now. Now, let's start a Jupyter Lab instance. We start it like the others, click on Jupyter, enter a password, which I've already created before, and once it's started, you're in. Embeddings extraction is our workflow that uses Clip to generate embeddings so that you can search for related images. You start this workflow exactly as you did object detection. Click on New Workflow, choose Embedding Extraction, and select your database. To visualize what embeddings do, we'll look at this image from before. Notice it has a Cocoa URL, so we'll copy it. And what we're going to do is we're going to run code that will grab our embedding from the workflow and return it into Python. So we're going to go into Jupyter Lab, and you're going to get in here with the same password that you had from before. I'm going to use some code that I've preloaded. Okay, we're going to verify that we can connect, and then we're going to have some code that will retrieve our image. We're going to paste the image URL that we had. And as we can see, this is our image. Now we're going to have some code that will take that image and get the embedding. As we can see, we have an embedding of 512 dimensions, which is what Clip produces. Now we're going to run a query that will retrieve the 5 nearest neighbors and use this code from our ApertureDB Python library to display all of them. As expected, the image itself is the nearest because it is in the data set, but the other images are very similar.